Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the CPU scheduling in operating systems. CPU scheduling. CPU scheduling is the process of deciding which process will own the CPU to use while another process is suspended. The main function of the CPU scheduling is to ensure that whenever the CPU remains idle, the OS has at least select one of the process available in the ready to use line. Here we have the arrival time, completion time, burst time, turnaround time and waiting time. First one is arrival time. The time at which process arrives in the ready queue is defined as an arrival time. Next time is the completion time. Time at which the process completes the executions we defined as the completion time. Third one is burst time. Time required by the process for the CPU executions. Fourth one is turnaround time. The time difference between the completion time and the arrival time we defined as turnaround time. Fifth one is the waiting time, that is time difference between the turnaround time and the burst time. Next one is CPU input output burst cycle. Here we have the diagram. First one is load store and add store read from the file. Here we have the CPU burst. Next followed by this we have waiting for the input output request and then store increment index. Here we write to the file, then wait for the input output request and then it load store add store read from the file and then wait for input output request. Here process execution consists of the cycle of CPU execution and the input output wait. Next one, process executions begins with the CPU burst. Next point, that is followed by an input output burst and then another CPU burst. Next one is CPU scheduler. The short-term scheduler selects from among the process in the ready queue and allocates the CPU to one of them. Queue may be ordered in the various way. CPU scheduling decisions may take place when the process switches from running state to waiting state and then switches from running to ready state. Third one is switches from waiting to ready state. Fourth one is terminates. Next one, scheduling under the 1 and the stage 1 and 4 is non-primitive and then all the other scheduling is primitive, that is consider the access to shared data, consider the presumption while in the kernel mode, consider the interrupts occurring during the crucial OS. Next one is dispatcher. The dispatcher module gives control of the CPU to the process selected by the short-term scheduler. This involves its switching context, switching to user mode, jumping to the proper location in the user program to start the program. Next point is dispatch latency. The time it takes for the dispatcher to stop the one process and start the another running process we defined as a dispatcher latency. Next one is scheduling criteria. Here we have the 5 scheduling criteria. First one is CPU utilization, second one is throughput, third one is turnaround time, fourth one is waiting time and the fifth one is response time. Next one, scheduling criteria. First one is CPU schedule, CPU utilization. In CPU utilization, keep the CPU as busy as possible. The ranges may be vary from 0 to 100%. Next scheduling criteria is throughput. Number of processes that complete their execution per unit time. And then for long process, it may be 1 process per hour. For the short process, the throughput might be 10 processes per second. Third one is turnaround time. The time in the interval from the time of submission of a process to the time of completion is the